Hello friends, welcome to my video on big data. This course is just to help you understand what big data is. So you must be hearing it many from many places like big data. I just wanted to explain like what exactly big data is in this presentation. Okay. So the theme of the course is large scale data management. What is big data analytics? What is data science and analytics? Okay. How to manage very large amounts of data and exact value and knowledge or gain knowledge from. Okay. What is big data? What makes data really big? There is no correct definition, single standard definition available for big data. Big data is just a whole scale diversity, complex, required new architecture, techniques, algorithm, analytics to manage and extract value of hidden knowledge from it. What it exactly means is you have heck a lot of data. Okay, you don't know what to do with it, you don't know what it means, so we just have to do store everything, and we have to do analytics. We have to analyze them and come up with some meaningful reports out of it. Okay, so that's what the big data is. It's very big. It's like a humongous in size. You cannot just process it using any kind of databases and things like that. Okay, so that's what a general definition. There's no standard definition for it, but that's what the general definition. The characteristics of big data. Okay, the scale, the volume, the data volume, right? It just increases exponentially. So last year we might be seeing one size, and suddenly in next year will be the size will be increased exponentially. For example, see there will be like 44 times increase from 2009 to 2020. That's what they predict, and from 0.8 zettabytes to 35 zettabytes. Okay, so the digital universe, which includes all the internet, all the Facebook, social universe, social media, it is you know uh, it is predicted to increase like 44 times by the end of 2020. Okay, so from zero point 0.8 zettabytes to 35 zettabytes, that's what it predicted increase. Okay, the data volume is increasing exponentially. So as of now, if you take any organization, they store their data in terabytes. So you might have been heard like Teradata, data warehouse appliance. Okay, wherein they store all the enterprise data, but it is not enough. The data is growing, and it reaches petabytes, exabytes, zettabytes, etc. Okay, so that's where the big data comes into play. The second characteristic is complexity, variety. So you can have like any data. Earlier we used to have like characters, numbers, blocks, and things like that. But now it's been changed to any type of data. You can get a social feed. You can get the view count. We can get pictures. We can get streams. We can get like what is the genes in the DNA, etc. Okay, so we cannot just stick with a certain data types. So the variety changes. It depends on the application which generates the data. Okay, that's what the second characteristic is. The third characteristic is the speed at which the data arrives. Okay, so uh, data, it's being generated very fast and need to be processed fast. Okay, so you get like heck a lot of likes, user feeds in Facebook. You get a lot of tweets per minute, per second. So we got to do analytics on those data to make some decision which would help the business. Okay, that's what the intention is. So the velocity of the big data is really fast. Okay, so examples, there are some examples. E-promotions based on the current location and the purchase history. What you would like, send promotions right now to store next to you. Okay, and healthcare monitoring. Sensors monitoring all your activities body. Any abnormal measurements require immediate action. Like they will have sensors to your heart. If there is any abnormal heart beating, they would just take an immediate action on that. So big data is mainly governed by three V's. One is volume, large amount of data, the size increases exponentially. The second one is velocity, the need to be analyzed very quickly to take appropriate action. A third is variety, different types of data structures, structured and unstructured data. You get tweets, blogs, videos. Likewise, you get lot type of different types of data. So these three V's govern the big data, as you can see here in the triangle. Okay, that's what the big data actually is. Okay, so that's what this slide talks about. And some make it the fourth V, that is called veracity. Veracity means data in doubt. They don't even know like what kind of data they have and what does the data means and how can we make use of that data. Okay, that's what the fourth V stands for. Because the data is inconsistent, it's very incomplete, it has a lot of ambiguities, it is latent. So some of the data you cannot define data like in data, DBMS. You cannot establish foreign keys and things like that. You just analyze the data as and when it comes. So you don't even know what the data is until unless someone really looks into it and find a clue out of it. Okay, how to harness the big data. Okay, so earlier you might have heard like two terms, OLTP and OLAP. OLTP is nothing but online transaction processing. Okay, when you go to the shop, you do a transaction, you get a bill out of it. That's the transaction. OLAP is online analytical processing, where we used to analyze the entire transactions that you have done across an enterprise. Okay, OLAP. So now there's something called RTAP. Okay, it's called real-time analytical processing. So that include like stream computing. It started in the late 2000s, and it's really becoming popular nowadays. So what we basically do is we just combine the OLAP and RTAP and make some informed decision. So when you buy something in a store, we send you a coupon um, to encourage you to buy something else from our store. So this should all happen at a speed of a sound. Okay, so that's the reason we use the RTAP. So this real-time analytical processing is what uses the big data and makes informed decision. Okay. So online analytical processing uses DBMS like Oracle SQL Server. Online analytical processing, it uses data warehousing techniques like Netisa, Teradata, and RTAP. Real-time analytical processing uses big data architecture and technology. Okay, so the technologies like Hadoop, Hive, HBase, Cassandra, MongoDB. So those kind of technologies supports big data. Who is generating big data? Yeah, social media networks. You might be seeing like heck a lot of people are using Facebook, Twitter, YouTube, Flickr, Instagram. A lot of social media there nowadays people are using. So if you wanted to check out some reviews, you log into YouTube. Okay, so those social media networks and all of who are nothing but ourselves. We ourselves generate the big data, and then we use it, consume it. Okay, so blogs, heck a lot of blogs. Like you have like millions and billions of blogs in the web right now. Okay, and that is one. The second thing is the scientific instruments like sensors in the road, the traffic sensors, um, the extraterrestrial SETI, search for extraterrestrial intelligence, and lot of sensors used to measure natural activities like to predict earthquakes, to predict volcanic eruptions. So those kind of instruments, they generate big data as well. Mobile devices tracking all objects at all times, so you track the GPS where you are and all those things. So those kind of things will also generate big data. And sensors, technology, and networks. Okay, so progress and innovation is no longer hindered by the ability to collect data. Okay, we can just collect the data, but by the ability to manage, analyze, and summarize, visualize, and discover the knowledge collected data is timely manner is a scalable fashion. That is what is very important. So we collect a lot of data. What the data actually means and how we can make use of the data is what big data actually does. Okay. So model of generating data has changed because we are in a new generation. Okay, earlier the companies used to generate data, so the newspaper companies, they generate pages and we read it. But now we ourselves generate data, like Twitter's real-time feeds, YouTube's review videos, Facebook comments, posting, and videos, and we consume it. Okay, so that's where the problem comes in. When we generate data, it is not controllable because we are like a massive amount of people generating data. It has to be analyzed. So that's where the model of data model has been changed actually. Okay, what is driving big data? Okay, the business value and complexity. So business intelligence, it is not it's not about predictive analysis and data mining. So ad hoc querying and reporting, data mining techniques, structured data, typical sources, small to mid-sized data sets. That's what business intelligence is. So existing business intelligence system, it's all predefined. Okay, but big data, you do optimization, predictive analytics, complex statistical analytics, what kind of customer are flowing in at what point of time, and what kind of products that customer is interested in. So those kind of analytics that we can do using big data, not using the business intelligence systems that we have currently. Okay, all types of data, many sources, very large sets of data, so we can just analyze how many people are coming and going out. Store traffic can be analyzed in real time, so those kind of things can be done using the big data. Okay, so you get a lot of business value, and that's where the investment comes in. Big data is more real time in nature than traditional data warehousing applications. Okay, so um, what is the sales? How is the sales happening in Thanksgiving Day? These kind of things are called big data thing. Traditional data architecture like Exadata, Teradata are not well suited for big data apps. Okay, shared nothing, massively parallel processing, scale out architecture are well suited for big data apps, which basically is like shared nothing is like if any of the node or any of there would not be any single point of failures. Okay, so the system will be up and running all the times. Earlier traditional data warehousing architecture, database, once the database goes down, you got to inform the DB and make sure it comes up. We have to wait until it comes up to make the analytics. Okay, but in the real world scenario, if we wait that long, we'll miss a lot of opportunity, we'll miss business. So we have to have an architecture which does not have a single point of failure. Okay, that's where the big data comes in. Challenges in handling big data, lack of software technology, 30% lack of analytical skills, insufficient budget on already using. Okay, so bottleneck is the technology, new architecture, new algorithm techniques are needed. Okay, so we don't even know what we have, what kind of data we have. Technical skills, experts in using native technology living with big data is very very less. It's a new field, so we cannot find experts in that field. What technology do we have? We have Hadoop is the only technology now we have for big data. We have Hadoop MapReduce, Mahout, Apache Headspace, Hive, Cassandra. These are the MongoDB. So these are some of the technology that we have for big data. Other big technologies are the Australian service in the cloud. Okay, these are like variety of technology that we have for big data. So you can see the this picture shows you like what are the different technologies has been supports big data. Okay, so how I believe like you enjoyed this session. That's all I have to talk about. Please subscribe to my channel to get more videos and learn more of data and data warehousing. Thanks for watching my video. This is Data Dawn. Have a great day. Have a wonderful life. Bye.